Let's look at this video. This YouTube has sent me this person's video, and so I looked at it. 346,000 subscribers. This person appears to be a female, and I wrote a comment there. They stating that also they put a pin inside here to support this load-bearing post. I don't think that was done. It's not shown done. There's no evidence that it's shown done, short of someone stating it. And then we look at the craftsmanship. This person is claiming to be a carpenter of some type, and you can clearly see that the base, if the camera doesn't have some weird, funky warping effect going on with such a short distance, which I don't think it can because this material is not warped. This is out of plumb, so this shows craftsmanship. But let's go to the video, and we're going to talk about the slope here.
Well, it's got to be cut at an angle. So how do you get that angle? Well, I'm going to show you how to cut that angle without taking a measurement.
So considering this is the same camera, I don't see warping or anything else.
Let's get started. Okay, so this is what you're going to need. You're going to need a pencil. Get a piece of... Okay, so that's why we do it this way.
So I don't see any drills, any pins right now, which they're going to claim in the end. There's no claim. There's no pins there. Nothing.
So what we're going to do is we're going to take our 4x4. We're going to place it on the incline, right?
I'm going to fast
You
forward.
get this plumb perfectly centered in the bubble. Perfect.
Okay, this is.
Okay, so I've got my scrap wood. I'm setting it on my miter saw, and now I have to determine the angle of this cut, and I've got to make the adjustment down.
And they're going to come to 26 degrees.
26 degrees. So this is a speed square. If you've got one, right?
Let's go back to the material. So it appears to be a number 2 pine. I thought it was. Can I get that? Yeah. Okay. This is where she's going to also claim, appears to be a lady, that she put a pin in there. Imagine if you were to put a hole in the center of this incline, a 1 inch, let's call it a 1 inch hole or a ½ inch hole, 1 inch hole. You're going to do some anchoring down, right? In this bolt, you'd have to epoxy it in and everything else. She called it a cleat. Well, it's never called a cleat anywhere, and that's not how you secure it anyway. You don't secure it by putting a cleat, whatever this definition of a cleat is internally. This is ridiculous. So the person didn't do it. Now you're going to see this is a load-bearing item, but if you were to, let me go to the section here, cross section, to drill a 1 inch hole here, what's left is an inch and a quarter all the way around this entire member. At that point, it's a bit of an incline, so it might be a little bit more based on the incline, 26 degrees. At that point, what's left on the outside of that ring, of the hole you just drilled, is the part that will resist sliding, if you will. And I'll explain that in a moment.
Well, we're back outside. This is our cut, right? So what we're going to do is we're going to stand it up. We'll stand it up. That looks really good, doesn't it? Looks like it's plumb, but let's check. It's right on the money. So what do I know? I know that I need to set the miter saw to 26 degrees without measuring it, just by using.
So here's the back porch, it appears, and this is some type of overhang, a roof load. I don't know what it is actually. Interesting.
Level.
It's not shown.
Okay, so our new post is in place. Now it's time.
Okay, new post is in place. Notice the bottom recycled materials here. And this is where it was supposed to have been drilled. You also had it by a knot. This is where you would knot if it was doing what this person's claimed to be doing, drilling a hole in the center and adding it. This is where you would not be, this is not what you'd want to see. That weakens the material right there also.
It's time.
That's a weaker spot.
To remove the supporting posts.
So there's the 20-ton jack, the raise up, if you will, to remove the supporting post. When they did that, I took notice here. I don't see this lifting up at all. But let's go.
Yeah.
But they jumped. But you know, you put this post in, and then you're removing your supporting post in that format. You're going to take the load off of your one post that you just put there, and then you're going to be reapplying it. it's just ridiculous. If it's an even cut, you will not be able to jack it up and pull out, and then pull. You'll be able to pull out the one post. When you lower your jack, you would not be able to pull this out. Okay, so let's follow this. This is all you needed, and you dial this down to release the load. But she is lifting it up to take off this other post that's supposed to have a load on it. It's a cantilever, because obviously if that's the load bearing, here's where this is. As you jack this up, this would then become loose. This is why you would just use something like this, or something you would knock out and the load would transfer back to your
Posts.
This would lower. You would just turn the release the load on this, and it would lower itself, releasing it. Now, if you ever do get caught up in something like this and you want to release it, use a Sawzall or try to knock these blocks out. Be mindful of this movement.
Yeah. There you go.
Yes, no hard hat, etc. But they work for themselves. It doesn't matter, right? All right. Now listen to this.
Okay, so I've got my post.
What they're going to claim is that she's going to claim is that they put an anchor in there. I'm sorry, a cleat. Yet this quality of craftsmanship, they're recycling this material. It doesn't hold water fully.
Installed. It's nice and rock solid. The fact that it was on an incline didn't matter.
Incline critically matters. You now have friction that you're trying to hold this on, and the friction would transfer to this imaginary cleat, if you will.
Able to make this cut, so don't be fooled, all right? It's not just that it's been cut at an angle. I've installed a cleat that's in the cement, and it extends up through the post.
And she said a cleat, and then she put her hand up to this depth here, which is craziness, right? Because if you put your finger up to this cleat here, how did you get a full-length post over top of that cleat, as you call it, this spike, if you will? How did you get your hand over that? I'm not sure if you guys can. Great. How did you get your post over that? How did you get your post over that and put this in place? If it's on a plumb, if that's plumb, you don't have the room to put it over top of and drop it down unless you've got this super elongated hole, and now you've got this terrible setup. All right, there is the material that is a recycled material, just a finished nail, so this wouldn't count as anything structural to help the supports transfer the load from one to the other. And we'll take a look.
So that, you get a real secure, solid connection. Okay, so there's the job.
And now you see that if you use a piece of paper now and you put it here, and you take a measurement from inside or outside, and put a dot on your piece of paper, you'll see that these members are not parallel. #plumb. All right, take care, guys. Interesting. So again, you'd use a plate, is what I wrote the person. The angle of incidence is what you're worried about. You're just dealing with friction here. And you would want a leveling base. A leveling base out of steel would be nice. And anchor it out here. So securing it out here, depending if this is can take an anchor. I don't know what this is, how thick it is or not. Or is it just decorative over top of some stone? It needs to transfer down to the footer, but obviously we have a lot of stone here. All right, that's how I'm going to terminate this. Wish you guys the best.